Hello, welcome to our video 4, resolution of vectors. We already established the fact that the magnitude of a vector is given by r is equal to x squared plus y squared. Now I want to look at the bearing theta. Theta is the bearing of the vector. Now let's call alpha the angle the vector makes with the x-axis. So if we are to show this on a diagram, we have our x-axis. Let's say we have a vector p, and this is going to be our alpha, the angle that the vector makes with the x-axis. Now p, the vector p will have an x component here and then a y component here, which corresponds to this. Now this looks like a right angle triangle, doesn't it? If we take OP and this, what do we call this? Maybe N. OP and it becomes a right angle triangle. With the angle alpha here, x becomes the adjacent and y becomes the opposite. And so if we are looking for alpha, we can use tan. We'll say that tan alpha is equal to y over x. And so alpha will be equal to tan inverse of y over x. Now, theta is the bearing measured always in a clockwise direction. So somebody will say to find theta, I just have to subtract alpha from 90 degrees. That only works for the first quadrant. And this will take us to our diagram here. Assuming this is our north, we are going to have 4 quadrants in our Cartesian plane. This is the first quadrant. We come down to the second quadrant, the third quadrant, and the fourth quadrant. So the formula for theta depends on which quadrant the vector lies in. For our first quadrant, we have a vector OP. This is O. We have a vector OP. Now alpha is over here because this is our x-axis. And this is going to be our theta. So as you can see, theta will be 90 minus alpha. If you take away alpha, 90 degrees minus alpha, take away alpha from 90, you get your theta. Now let's come to the second quadrant. Let's say we have a vector OQ. Again, our alpha, the acute angle the vector makes with the x-axis. For theta, we measure from the north in a clockwise direction. That is the bearing, all the way here. So we can see that this is 90 plus alpha, and that will give us theta. For the third quadrant, again, this is our vector OR, and it will make an angle of alpha with the x-axis. This is the extension of the x-axis. And our bearing from the north all the way to the vector R, that is our theta. So how do we get theta? This is 90, 180, and all this is what? 270. So if we take away alpha from 270, we are going to get theta. 270 minus alpha will give us theta. Let's look at the fourth quadrant. This is a quadrant or a vector OS. And again, our alpha is the angle the vector makes with the x-axis. Our theta, measure it from the north in a clockwise direction all the way to S. That's a bit. Okay, so that is our theta. So we see 90, we see 180, we see 270. If we add alpha, we get our theta. So for the fourth quadrant, we have 270 plus alpha. So these 4 formulas depend on the location of the vector with respect to its quadrants. We will take some examples in our next video.